How do architects address climate challenges in building design? 1. Introduction to climate-responsive architecture. As climate change poses growing challenges, architects are increasingly focused on creating buildings that not only withstand these challenges but also minimize environmental impact. Climate-responsive architecture involves designing buildings that adapt to local climatic conditions, reduce energy consumption, and promote sustainability. 2. Passive solar design. One of the most common strategies architects use to address climate challenges is passive solar design. This approach involves orienting buildings to maximize natural light and heat from the sun, reducing the need for artificial heating and lighting. By strategically placing windows, shades, and thermal mass materials, architects can optimize energy efficiency and create comfortable indoor environments. 3. Green roofs and walls. Green roofs and living walls are increasingly popular in urban architecture. These features provide insulation, reduce the urban heat island effect, and manage stormwater runoff. By integrating vegetation into building design, architects can create microclimates that cool buildings naturally and contribute to biodiversity in urban areas. 4. Use of sustainable materials. Architects are turning to sustainable materials to reduce the carbon footprint of buildings. Materials such as recycled steel, bamboo, reclaimed wood, and low-carbon concrete are favored for their durability and minimal environmental impact. Using locally sourced materials also reduces transportation emissions and supports the local economy. 5. Water conservation and management. Water scarcity is a significant climate challenge in many regions. Architects address this by incorporating water-saving technologies such as low-flow fixtures, rainwater harvesting systems, and greywater recycling. These systems reduce water consumption and ensure that buildings contribute to sustainable water management practices. 6. Energy-efficient building systems. In response to the growing demand for energy efficiency, architects integrate advanced building systems that reduce energy consumption. This includes high-performance insulation, energy-efficient HVAC systems, and smart building technologies that optimize energy use. Additionally, incorporating renewable energy sources such as solar panels and wind turbines can help buildings generate their own power and reduce reliance on fossil fuels. 7. Climate-resilient design. To address the increasing frequency of extreme weather events, architects are designing buildings with resilience in mind. This includes features such as elevated foundations to protect against flooding, reinforced structures to withstand hurricanes and earthquakes, and materials that can endure extreme temperatures. Climate-resilient design ensures that buildings remain safe and functional in the face of climate-related disasters. 8. Adaptive reuse of buildings. Adaptive reuse involves repurposing existing buildings for new uses rather than constructing new ones. This approach conserves resources, reduces waste, and preserves the historical and cultural value of buildings. By retrofitting older structures with modern, energy-efficient technologies, architects can extend the lifespan of buildings while reducing their environmental impact. 9. Bioclimatic architecture. Bioclimatic architecture involves designing buildings that respond to the specific climate of their location. This approach considers factors such as wind patterns, humidity, and temperature variations to create structures that naturally regulate indoor conditions. For example, buildings in hot climates may feature shaded courtyards and natural ventilation to stay cool, while those in colder regions may use compact forms and high insulation to retain heat. 10. The future of climate-conscious architecture. As climate change continues to influence the built environment, architects will play a crucial role in developing innovative solutions that mitigate its impact. The future of architecture will likely see increased integration of sustainable practices, renewable energy, and adaptive design, creating buildings that not only meet the needs of today but also contribute to a more resilient and sustainable future. In summary, architects address climate challenges through a combination of passive design strategies, sustainable materials, energy-efficient systems, and resilience-focused features, ensuring that buildings are both environmentally responsible and capable of withstanding the impacts of climate change.